Hi, I'm Dale Farnan, and this is my ENME 489Y final project video. So, a little bit about ENME 489Y. The class is called Remote Sensing, and the main goal of the class was to build a LiDAR sensor, go out on campus and scan an object using it, and then translate that data into a 3D point cloud. So, the object I chose was this fire hydrant. Some pros were that it was small and the laser showed up quite well on this white kind of shiny reflective surface, and also it had good access from the front. There's a sidewalk off the lower right corner of this image. Some cons were that the access from the back of the hydrant, the ground was uneven and hilly, and from the sides you can see these rocks and bushes obstructed me from being able to get good scans from those areas. So, a little bit about my LiDAR sensor. I 3D printed the chassis. Here you can see a Raspberry Pi powering a Pi camera, and that's the receiver part of my sensor. Down here it's an Arduino Uno powering a line laser, and that's the transmitter part of my sensor. You can see the line laser showing up on the wall here. Other aspects of my sensor include the tripod to hold it up, and this old iPhone to take IMU data on what angle it's at when I'm scanning. So this is an active scanner because it sends out data with this laser and then picks it up with the camera. If we were just using the camera and we didn't have a laser, that would make it a passive scanner. So I'm going to show you a video of me scanning a trash can in my apartment in order to calibrate my sensor. Here we are taking ranging data in our controlled environment, which is my apartment. We're scanning a trash can today. So we've got our VNC connection to our Raspberry Pi. Here's our device. We can see this IMU angle says 10 degrees. So we're going to go on and enter 10 in here. Run data collection 2. It's confirmed that the IMU we entered is 10, and it's all done. Let's take a look at our 10 photo here. You can see it. So as you can see, we got some pretty good data for calibration, and it went well. The next step was to take our scanner into the real world and actually scan the fire hydrant with it. So here we are in the real world doing data acquisition. One possible problem is the lights coming from that store in the background. Did not anticipate that. I'm trying to have the fire hydrant at the perfect angle to block them from the camera. We'll see how successful that is. We've got our IMU data. It reads 9 over there. So we're going to go ahead and run our code. Asking for the IMU, all 9. Enter. Confirms that it's 9. And it's all done. You see our image 9 popping up over here. Now we're going to adjust this so it angles up just a little more. And take some more data. So the next step was to apply a HSV mask in order to go from this picture to this picture. So basically the only thing I care about in this picture is this laser showing up right here. So we translated the colors from red, green, and blue to HSV colors and then played around with the filter until we were able to get this picture, which is just picking up the laser that we have. And then once we have a bunch of these pictures for the scans from the front and the back, we put them into a MATLAB file, which turned them into a bunch of points. So once we had those points, we ran another MATLAB file, which basically loaded in the points here. And then in the text down here, we combine them and transform them into a 3D point cloud, which I'll talk about a little in this video right here. Here's the code I used to make the 3D point cloud of my fire hydrant. This top 4 statement here loads in the data that I took when I scanned the front side of the fire hydrant, which is this side here, and color codes it blue. This bottom for statement loads in the data I took from the scan of the back side of the fire hydrant, transforms it so it matches up with the front side. We see the transforms here, and then color codes it red for the back side scan data. So as you can see, we got a lot of data here. We even managed here and here to capture the chains that are hanging off the fire hydrant, which you can see. So let's spin this baby around. You can see we got the chains hanging off the front too, as well as that large front module. It matches up pretty closely. As you can see, the bottom of the back side is a little crooked. We may have to do that again, but we got some nice detail on the two parts that stick out the sides of the fire hydrant. And again, we were able to get those chains hanging down off the front here, as well as the large front part sticking out here. And we were able to capture the entire fire hydrant with 2 scans. Since it is round, we were able to get just about all of it. So the final part of the project was attempting to take that point cloud and put it into a 3D mesh, which we have here. We didn't have a lot of success, but you can see the shape of the fire hydrant. This is the front view. And it was a process of trial and error, trying to adjust the normals so they were all pointing out of the mesh instead of having some pointing in and some pointing out. Then our mesh looked very ripply and did not have the shape of the fire hydrant. So thank you for listening, and I'll see you next year.